let's move to the next one. We have Kundan talk about real-time high concurrency use case in fraud detection at Games 24/7. Kundan is a senior engineer at Play Games, and he has experience in building data pipelines, ETLs, and reports for more than 8 years. He's mostly worked with Spark, Impala, and Hive-like tools since the last year. And he has been using Druid for real-time use cases and finds it very, very useful and appropriate for these kind of applications. I will let Kundan share a screen and talk about the scenario around fraud detection. Kundan, over to you. Thanks.
Thank you, Shrikant. Hope you can hear me. So,
yeah.
Okay. So thank you everyone for joining this session. So my name is Kundan, and we are going to talk about how Druid has been a crucial member of our data platform. We call it DAS over here, and how DAS is serving this real-time high concurrency data requirements for fraud analysis using Druid. So this is my intro. So my name is Kundan, and I'm SD3 at data engineering team. And me and my team usually works with building data pipelines, data platforms over here at Games24x7. So this is the agenda for today's talk. I'll begin with a quick introduction of my organization, Games24x7. Then we'll talk in brief about our data platform called DAS. And then we'll see that how DAS, what kind of data requirement DAS gets. And one of those data requirements is for fraud analysis. We will discuss this use case scenario. And then we'll see how Druid is helping us serve these kind of data requirements and how it exactly fits Druid, how Druid exactly fits the requirement over there. And then we'll see the result of this implementation. And finally, we will have, then we'll see that what are the future steps that we are planning with Druid, what are the current work that we are working related to this. And finally, so Games24x7 is a leading online gaming platform. We offer, Games24x7 offers multiple games in both casual and skill games, real money portfolios. Rummy Circle is one of our most popular games. Rummy Circle is an multiplayer online game, which offers playing Rummy online. And in fact, Rummy Circle is India's largest online platform for playing Rummy. My 11 Circle is our offering in fantasy sports. So in fantasy sports, where people usually build their own virtual fantasy team to compete with each other. And we have been my 11 Circle have been in market since last 2 years. And in these 2 years, it has grown many folds to become like one of the most loved fantasy sports game in India. Ultimate Games is our casual gaming studio, which has produced many casual games for India and for our global audience as well. And it is continuously building more and more casual games like KT Spit Park, Ultimate Team Patti is one of our most popular games, and so on. So these are a few of the games under Games24x7 portfolio. And this is the data story at Games24x7, the kind of data that we receive. At our fantasy end, we are capable of handling hundreds and thousands of concurrent players. And then these players have created millions of teams and are continuously creating teams for on our fantasy platforms. Our Rummy Circle receives tons of data, TBs of data, and actually consumes most of it, of that data for its analysis and other purposes. Our casual games like Team Patti is among the top grossing games on Play Store. We have millions of users. We have a very vast user base, and it's ever growing. And then we have we have other metrics also. These business metrics are just to give you a glimpse again that what kind of data that we receive and what is the processing that we need. And this is the data flow at Games24x7. This depicts the data flow. So it all begins at our players, our users, generally playing their games on their devices, and they continuously create events. Now these events could be click events or login events or deposit events. These all events have a dedicated service behind the game, and these services are actually dealing with those respective events. So click event would be handled by a clickstream service, and a login event or a registration event will be handled by acquisition service, and so on. So these service receives these raw events, and what we do is we have an enrichment layer. So each of these events will be enriched with some additional meta info with our existing databases, and these enriched data, these raw events enriched with some meta info, will be published to our topic and in Kafka, and this Kafka layer becomes our de facto go-to place for consuming streaming data. So whatever service that needs streaming data will consume to these of the Kafka topics. So the consumers could be our backend services, or it could be our taxonomy services, which we build for, which deals with our ETL and other pipelines. And then we have data as a service platform. So we are going to talk about this particular platform. So a bit about DAS. So DAS is our data platform. So this is built for our internal teams, so they could access data in the most efficient and convenient way possible. So what we need to do is that DAS is a platform. It has its own UI and API services where teams can create their jobs describing what metrics they need, and they would submit this job, and whenever they the result of this output of this creation of job will be an endpoint, a REST API endpoint, and whenever they call for this endpoint, this will fetch the data that they need. So it becomes very simple for them, and it has helped them to access data in a very easy manner. So this helps in data democratization. Again, building a platform like DAS has helped us minimizing our pipeline-like structure. Previously, we used to build pipelines for our requirements, for our data requirements. Now everything is gradually moving towards DAS. So it is helping us save time and cost as well. With DAS, we are capable of now handling real-time data requirements very easily, because it is a central system that already is running with already serving data in real time. So hopping on a new requirement is not that difficult. Also, DAS has one of the components of DAS is data catalog. Data catalog is an internal system that holds all the business metrics that is being built via DAS or some. So this helps us to streamline our business logic. So that means what a single metric will hold one single business logic for all of the team members. So this business metric, once defined, it is available to all the team members, and again, means it has same logic for all the team members. So it streamlines our business logic. So, and also it helps us in reducing redundant processing. We will see how it helps us this. This is a quick comparison between our legacy system, our pipeline-based approach, and our platform-based approach. In pipeline-based approach, what we were doing is that this was our Kafka, the central Kafka that we talked about. And from that Kafka, the enriched data would be consumed using Spark streaming services. And these data would be written on S3, either in JSON format or in Parquet format. And we had multiple query engines to query on it. Now, whenever a requirement used to come from a team, one of our data engineers would pick a query engine or a set of query engines and churn out that data as per requirement, and build a pipeline for that particular requirement for that particular team. Further, that team would
hello, Kundan, can I ask you one question? So I just wanted to understand,
sure.
like in your the first pipeline which you explained, right, where you are doing a Spark streaming, right? You're reading your enriched data through Spark streaming, and you are writing it in Amazon S3, right? So is it some aggregation based pipeline? Like what kind of logic are we doing there?
No. So it is raw, cleansed up data. You can say that it is just a processed data. Let's say that maybe we have data in this map format, right? Nested JSONs. So what we do is we simply clean up that data, maybe streamline that data, and then this pipeline, what it does is the business logic or the minimal business logic that a data engineer can implement will happen in this part. So this one would be a cleaned up data. This just you can think it of from Kafka to Kafka. That's it.
Okay.
And then we create data marts. You can say these data marts are being created using these ETL jobs, and using from those data marts, further data analyst or data scientist would create their own custom metrics.
Right.
Okay.
Sure.
So with this pipeline, again, these team members would use this data that has been churned out by data engineer, create their own requirements, help their own requirements using their own set of tools, and creating and publishing their own set of metrics. Now, the thing over here is that with every requirement, some part of work had to be done with data engineers, and also some part of work with the team members. Along with that, the problem is that whatever metrics, the final metrics that is being generated, now this could be duplicate because this team does not know that the metric that they are going to generate might be generated by some other team members as well for the very same day, for the very same logic. Now, this is redundancy of process. Now, because they will be using their own set of hardware, so this adds up to the cost as well. Not only processing, not only time, but to the cost as well. So we identified these problems and the motivation of DAS, the motivation for building DAS was these points. So with DAS, now we have a central platform of for serving data, and any of the team members can come to DAS using its API and UI services, and then create a set of jobs. So what DAS will do is it has already a pre-populated data catalog that we already have that we data engineers have designed, or if someone wants to create their own custom metrics, they can do that as well. So this catalog will help these engineers, these team members to identify or to browse through the metrics that they need. Now they will pick from these metrics what are their requirement, and then create a job out of it, and they submit it. Now, as soon as they submit it, depending on the metrics that they have selected, our DAS will identify whether it should be a batch pipeline or whether it should be a real-time pipeline. And depending on the requirement, so let's say it's a real-time requirement, so it will pick Druid, may pick Druid as a query engine, and then automatically create query for those metrics in the DAS and return an endpoint. Now, whenever these team need that fetch that data, they just need to call that endpoint. This endpoint will directly go via DAS to this query engine, will execute the data, and then return the response back to the team. So this has simplified the process a lot. Now these teams do not need to know where data is stored, in which format data is stored, what query engine to use for accessing those data, and even they don't need to write any queries for that as well. And along with this, the redundant processing has also reduced a lot. So this is what DAS is. So this was about DAS. So DAS is DAS is what? DAS is our data platform for serving data. But for specific use cases like this fraud analysis, there are different services who will be working for this. And DAS is only for serving those data. Now we are going to talk about the specific use case like fraud analytics. So fraud analytics is something that is very crucial for us, and it is this is done by a specific team called risk team, whose job is to identify risky players and fraud players, and they do this using their own application called risk role engine. Now this risk role engine is a event-based trigger system. That means during a game, during a player's life cycle, we will have multiple events, from its registration to login to deposit to bonus release, and then finally when a game settles, means end of the game, and finally withdrawing amount from game wallet to their actual account. So these are events. So what the risk rule can do is they can create a set of rules on one of these events or maybe multiple events to identify a player who follows a pattern. So a player, just to give you an example, like if a player is constantly generating some bonus amount, right, and constantly withdrawing it, so this may create suspicion. It may be a false positive case, but this may create a suspicion, and that particular player may be marked for further analysis for fraud analytics. Right. So these, what this risk rule engine does is that it applies its logic on particular events. So whenever a player have this settlement event, maybe a set of rules will be triggered against him. So whenever he receives a bonus, maybe a set of rules will be triggered against him. So this risk rule is an event-based trigger system. Now, there is provision that different players could be colliding or helping each other to win. So this maybe there are a set of players who have somehow reached to the same table and they are helping each other to win. Right. So this is also required that the players should be compared with each other. So something like that, one player is compared with other player, right? Maybe how many times these two players have played together and what is the percentage of win this player wins, what is the percentage of game this player wins whenever these two players play together, right? So these kind of requirements should be there, these type of data points should be there. And why this is important, why having this kind of risk system is important, because it is very crucial, it's very critical for games like us that we provide a fair play experience to our players. This boosts their confidence, right? That this is a platform where unethical practices are not there and they feel comfortable to play their game. Right? This is very crucial for us. And along with this also helps save us a lot of money as well. Now, what are the challenges in building this kind of system in real time, right? Real-time serving systems. First thing is why we need real time in the very first place. So real time because, as I said, someone might be playing a game, right? As soon as settlement happens, the winning amount will get credited to his game wallet. And as soon as it has credited to game wallet, it may take a matter of minutes maybe to withdraw that money from game wallet to his bank wallet. And once this is done, once this withdrawal event is done, we cannot do anything. The amount has been withdrawn. We cannot stop that player from withdrawing. So whatever action needs to be performed for this particular example, what I'm talking about, this has to be done between these two events. So these may happen within minutes, as I said. As soon as the game ended, the player will start withdrawing money. We will have to stop or we will have to decide within that period as well. So this has to be a sub-second system. The response should be very quick. And also, this is the number of requests that we receive is very high. Now, how this is very high? As I said that one player may be compared with other player as well. So even if we compare, let's say that this is our winner, and if we are comparing only the winner with the other players, those are on table, it creates, for a 6-player table, it creates 5 combinations. So in a second, we have hundreds of settlement going on. So hundreds of settlement multiplied by 5 creates like 500, 600 requests per second, right? And these sums up to around 30,000 requests per minute. So the system has to be very robust. It has to handle thousands of requests per minute. And third point is this is a 24/7 running system, right? This cannot go down because it is constantly working on. Our game is working 24/7, so the system has also to work 24/7. So this has to be always available system, a very high available system, and also it has to be very much scalable. Scalable because the game are not the requests from games are not constant. During morning hours, people usually don't play that much game, right? During evenings, the evening hours are our peak hours, and also during festivals or during some promotional campaigns, the number of games that people usually play increases, right? And as the number of games increases, the number of requests will also increase proportionally. So the solution for all these we find was in one place was in Druid. Now, for those who have no idea what Druid is, this is just an overview of a high-level architecture of Druid. So Druid is a system that has multiple components. It has a master layer, it has query layer, and it has a data server layer, right? Now, master layer internally have two more services run. One is called coordinator and one is called overload. Coordinator is the one which you can think it deals with the data movement. The data from real-time segments moving to historical segments. All these things will be done by coordinator. So where is your data actually? On which server that data is? All these information resides on Zookeeper, but the coordinator deals with it. Overloads are the thing that deals with task management. So coordinator was for data management, overloads is for task management. So what is your ingestion task? What is your compaction task? How they are performing? And what configuration, if you want to control them, you will have to use overload APIs to do that. Right? So these all things have been done by master. Now, whenever you want to query something out of Druid, you'll be submitting your queries directly to brokers. Right? So broker is a component inside your query layer. Router is an optional component which provides you that UI interface for Druid. So it is very important. But your major query is being served by brokers. So whenever you want to query Druid, you'll submit your query to your broker. Your broker will distribute depending will have a depending on the requirement, distribute your query either to real-time or historical segments, and the data will get written back to the broker and written back to the client. Right? So these are the three layers along with some external dependencies of meta storage and Zookeeper and deep storage for this purpose, for backup purposes. And this is our implementation of Druid at Games24x7. So we will begin from here, right? So this was our Kafka. This Kafka is constantly receiving events. Now let's say that our risk rule engine has configured a job, a risk rule job to Dash that for a particular user, I will send the user ID, right? And on a particular event, let's say the event is bonus, right? On a bonus event, I'll send a user ID, and I want to check how much of amount has been withdrawn from that user in the last 24 hours. So this time may be variable, this user ID may be variable, but once this job ID is submitted, now Dash knows what query is to be executed, and these parameters to the query will be provided by risk rule and runtime. Okay? So let's say we have received an event called bonus, and in that bonus, we know that user ID is 1234 maybe, and then risk rule calls Dash that okay, these are your parameters. I want to know for this particular job ID, this user ID 1234 for this time range, what is the result? Result over here is, let's say, what is the amount withdrawn, right? Now Dash knows that from this job ID, it knows that it is a Druid query. Right? So it will make a call to broker via HTTP. At our case, we used HTTP to call that broker. Now this is another beauty of Druid that we can, directly query Druid using HTTP connections. Simple. So it will make a call to your load balancer. Load balancer, behind the load balancer, we have multiple broker instances. And once the query is received, so the broker knows that which data source to be queried. Data source like something like table, which table to be queried, right? And with the help of, again, coordinator and Zookeeper, broker exactly knows that which segments are on middle manager in our real-time segments and which are on the historical segments, right? So let's say that we have queried for 24 hours. Now broker will know that how many segments needs to be scanned. Let's say we have distributed our segments in hourly manner, right? So 1 hour, 1 segment, 1 hour, 1 segment. So it knows that, okay, the current segment is on real-time, is a real-time segment. The rest segments are historical segments. This broker knows that. And exactly it also knows what are the location of those segments. So it will divide that one single query that we submitted into 24 different queries, each query corresponding to one single segment, right? And let's say this real-time segment query goes to this one of the peons, and the rest are going to our historical segments. Now, what are these peons? These peons are actually the ones who actually consume data from Kafka and also serve your real-time queries, right? Once this task duration that is assigned to this peons while beginning this ingestion process, you will assign that these peons should run for these task duration. Once that task duration is over, this will hand off your data to deep storage, and from deep storage it will be replicated back pushed back to your local historical nodes. Okay. So this data consumption is continuously going on along with our, now we have queried for the data. The response will come back from our middle managers as well as our historical settings back to the brokers. And the brokers will have these buffers used for group by or anything that we might have submitted. It will use those buffers and collect all the data in those buffers. It will finally calculate the result and return back the response back to your DAS. Now DAS will return back this to REST2, and this will say that, okay, whether this user was a fraud user or potential fraud user or simple player. This is how Druid is helping us this entire thing with our integrated with our DAS. Now that we are using these type of instances, our broker are of C5 4x large, and most of our data servers are C5 and large, means CPU optimized. And the type of query that we use mostly are of scan kind of queries, something like we want to look up that whether in the last X hours, how much amount has been deposited, or how much, or whether any amount has been deposited by the user or not. Or something like if bonus has been released for this user, what type of bonus has been released, whether it was in form of points or in cash or something like that. And also, as I said, we check commonality between players. So one player compared to other players. So there is also provision of having joint queries, right? Joining self-joined queries. So joining one player with other player and then check what is the common points that they share. So this is the result of our implementation. So we read it out to you that we currently receive something around 20,000 requests per minute, as I said earlier. And this is our maximum plot of our time. So you can see that sometimes we receive our response back, even it reaches 60,000 milliseconds. That means it takes sometimes a minute. But mostly our average response time is within 700 milliseconds, from 450 to 700 milliseconds. And that's fine for us. Yes. Having something within a second, it is pretty much good with us. So these are from our load balancers, the stats from our AWS load balancers, behind which we have our Druid brokers. And these are the internal metrics that Druid publishes. And from here, we see that our queries are being actually served between 500 milliseconds on an average. And these are the number of connections that Druid brokers are making. This is constantly between 200 to 250 connections per broker. So 2 brokers, that means around 500 requests per second. So the future that the current work that we are doing on Druid is that now we are exploring how to containerize our Druid. So currently we have EC2 instances. So every time we scale up or scale down, we'll have to deal with the entire EC2 block, entire EC2 instance. So we are looking and exploring that how this can be containerized and what are the potential benefits that we can gain from it. Also, we are working on auto denormalization. So one of the most expensive queries that you will see in Druid is join operation. So if you have a large number of concurrent operations in join, this is a very CPU exhaustive process, right? Instead of having joins in the runtime, it is recommended that you create a denormalized table, you join your data beforehand, and then publish it to Druid. So it will be much more optimized. So what we are working now is that how we can join our requirements, how we can join data right away from Kafka and dump into some other Kafka, and then consume it into Druid. So auto denormalize data directly into the Druid. So after that, as our requirement grows, more and more use cases coming in, we want to stick with our SLA. So we will explore multi-tenancy in Druid. So you can have multiple tenants on your Druid cluster sharing the same resources. And currently, prioritization and laning is not high priority to us because what we are dealing with currently is with our applications. So applications deal with near real-time data. So every query that we receive, every request that we receive is already highly prioritized. So this prioritization and laning will come into picture when we are dealing with dashboards where people, multiple teams will have their dashboards on Druid, and then we can prioritize their requirements. So this was all about Druid and DAS at Games24x7. So Druid has actually helped us a lot in focusing mostly on how we can build and expand our DAS, our data platform, and taking care of most of the requirements, most of our questions that we had. We had worked with, we had tried out multiple in-memory and indexing kind of databases. But what we found in Druid was an amalgamation of all the requirements that we were looking for with all its helpful APIs. And with DAS growing, our business stakeholders are also quite happy with it. So overall, it has been quite a journey with Druid. So any questions now?
We have few questions in the chat. Thank you, Kundan. It was great learning a Druid success story. And so I have few questions. First one is from Dipanshu. Dipanshu, do you want to read out your question? Just a minute. I think you don't have the permission to unmute. Just a minute. Let me fix that. Yeah, you should be able to unmute yourself now.
Yeah, thanks. Hey, thanks, Kundan. That was a real good session. So Kundan, just a quick question, because you were talking about you have a data catalog and you are using this as a kind of a repository where any of your business user can come, or maybe any of your data ingestion team can come and identify the key KPIs. So first question was basically that your data catalog is an homegrown, and that was first one. And secondly, when you're talking about that, you to decouple the KPIs so that it's not being repeated. So that's again done in, because earlier I was thinking that's a SQL you are using, but now I'm rather changing my question to that is basically Druid you are using for your KPI also. And how are you defining the business logic also within for the KPIs as a kind of a stream?
Okay. So yes, first thing is it is a homegrown catalog. It's not KSQL one. Though KSQL is part of our stack for streaming data, but the catalog is a general purpose thing that we have built for the entire DAS. And how, what is this metrics that we have in DAS is that we know that from our previous work, that we know that these metrics are mostly used, something like count of games or maybe win of players, right? What is the revenue generated by these individuals? So we know that how to calculate these things, right? So what we have done is we have already written the logic behind it. So whenever on the UI, if you imagine that on the UI, you are presented with the option like count of games. So you select the count of games, and behind the scenes, the logic is attached to that attached to that metric. Right? You can name your metric anything. So maybe you have selected count of games, and over here you can select that Kundan's metric. So you can name it anything, you can give it an alias, but the logic behind this is attached to that metric, and the logic we have already pre-populated. So the logic would be something like in simple SQL terms, if I say that count game IDs, right? Count distinct game IDs. So these logic will be attached to that type. Now this is what predefined logic is. Now if you say how a user can build their own metric, so there is a step-by-step process for it. So first thing is that they will have to select what event they are interested in. So as I said that most of our things rotate around on our events. Our players usually generate events. So it may be a login event, or it may be just a click of a button. So whatever events are present in the catalog, you can build metrics on top of that one. So currently, let's say that we have, for example, we have like 50 events in our system. So you can only use those 50 events as of now. If you need something additional that is not present in the event, you'll have to contact us, and manually we will build it for you, or we will start an development process for that. So let's say that your requirement is within those 50 events. Once you select that event, now we will pick up that these events belong to which data source, which table, right? And depending on that table, we'll populate what are the dimensions available for that event. Now you have to select the dimension. Next, you have to select the function for it.
So,
And
my apologies. So basically, you are designing a semantic layer, kind of a semantic layer. Okay.
Yes, we can think it of as that. So yes. So again, once the individual, now things from that how this is helping us reducing that redundant process, right? So once the user has built this metric and it is submitted to DAS, it is verified that yes, the logic is correct. So now this metric will be visible to all his team members along with the other stakeholders as well. Right? So next time if someone comes in, so this description with this metric will be available to them as well. So this is usable.
Got that. Thanks.
Yes. Thanks.
Thank you for answering that, Kundan. Next question is from myself. I noticed that you are using C5X9 family for the data nodes. So I'm assuming you are using EBS for historicals. And I wanted to know how's the operational experience in terms of performance.
Yes, true. So Abhishek, it has been a hectic year last year, as Eric also mentioned that configurations, you have to play a lot with your configurations. So yes, onboarding Druid was not a one-day task. It took us time. Apache Druid, the open source Druid. It took us a lot of time. But thing is, yes, our historicals on EBS, right? And what we do is that our requirement is such that we don't deal with very stale data, something like a month-old data or seven days old data, because the requirement is something centered around current what is happening today. Right? So we hold most of our data actually in memory in P1 itself. That's why I was asking Eric also that how to optimize it. If I could get some, and actually I got some. So so most of our data is actually held in the media manager layer itself, and the data layers that why we are using C kind of processing is that for currently we are actually moving out from C instances as well, but our actual use case was something that it was using joins, and when with large concurrent cases, if you use join, your CPU will spike a lot because of those joins. Those threads will be always busy because they are joining, they are performing these joins. So that's why we needed, that was the need of the hour, that we use CPU optimized processes instances. And now as we are denormalizing our data, now we are successfully transitioning from C instances to our R5 8x large kind of instances.
I see. And in terms of like EBS versus local storage, did you evaluate that as well, or EBS? And in terms of performance, EBS is fine.
No, yes, EBS is sufficient for us, because as I said that maybe 30% of 70% of the queries will be served from the real time itself. So we haven't done such benchmarking that how local and EBS will perform, but for us, EBS is working fine.
Okay, thank you.
And EBS and GPU.
Then we have one more. Yeah. Okay. I see. Yeah, there has been like one GP3 as well that has come.
Yes, correct.
I think it's more expensive too. Well, thank you. And Robin, do you want to read out your question?
Hey, hi Kundan, thanks for the talk. My question actually is, I probably get this feeling that the accuracy of the results might be critical for the sort of use case you have, right? Because you're trying to do some fraud identification, etc. And I was just wondering if there are any scenarios in the Druid ecosystem where you might actually not get a complete accurate result, but you might get a partial result, right? I mean, you said there are hourly peons are reading hourly, and there is a segment gets finalized every hour, right? So if a peon gets restarted, then it might not have the latest data. It might not have caught up to that, right? And so how do you handle those scenarios, and what is your mechanism around?
So Robin, first thing is that when peon is transiting, it is handing off the data to historical, the P1 view is still present. Means, it does not kill itself until the data is completely moved to historical is already active, and the other peons will start ingesting data, but this peon will stay there until the historical has become active. So this is an internal mechanism that Druid itself handles. Means, we haven't done anything over it. It's just out of the box. And also regarding partial data, so initially when we were working, we had seen that it was not partial, but something like we were expecting 20, count of 20, but we were receiving 19 or maybe 21, something like that. And that was because of the, what you say that, the probabilistic thing that Druid uses, right? So if you turn that off, it will return you the exact count of it. So, and also in our system, because the user is, so this is not a flaw actually, but this will not bother us that much also, because once a player has done perform an event, it will means, let's say it has done a settlement event, right? Means it has ended a game. The user, if for some reason we miss this user this time, on the other event, on the other settlement, this user will be analyzed again. Right? If this user is not marked for the first time, this user will be analyzed again. And maybe because in the game there are multiple settlements, so maybe if this settlement is missed, this we haven't seen this yet, but even in the scenario, I'm just hoping if something happens like this, in the next settlement, this user will get marked. So I haven't seen any partial data that has been received until unless all of our systems are healthy. If Beyond is healthy, if historical is healthy, I haven't seen anything like where partial data is received.
Sure. Let me ask a specific scenario in order to clarify my question further. Let's say, so you have hourly segments, right? And let's say at 50th minute, because the segment will be finalized at 61st minute, right? At 50th minute, a peon process dies or the node dies and the peon has to be restarted. Right? Now it has to start reading data from Kafka, for the entire hour, right? And it has to start reading from that time. And when it is reading, it might respond to queries, but it will not have processed that data for last 50 minutes, right? It wouldn't have that, and you might get some partial responses, right? I'm asking this because it's a problem for us as well, and then we have applied such mechanisms to find that.
So I'm not 100% sure, Robin, but the thing is that we have replications of tasks, and even if one peon dies, maybe the replication will kick in. I haven't tested it yet, just an assumption. Maybe the replication will kick in and then it may serve that requirement. But yes, I haven't tested it yet, and we haven't seen such scenario. But I hope that replication will handle it. Replication of task will handle it.
Sure. Okay, thank you.
Thanks, Robin.
All right. Any other questions for Kundan here?
Kundan, I have one more question. I think it's just an extension to Robin's question. So basically, there might be scenarios where you have a lag in the real-time processing, right? Could be possible, right? When you are indexing real-time indexing from the Kafka streams, right? I just wanted to understand, like, is your use case similar to like reading from Kafka and doing some aggregation and then persisting, or there is no such use case for you? And if there is any lag,
yes,
how to tackle that?
So there is use cases where we actually do aggregations in runtime. Means we are creating rollups, and there are use cases where we are having the time series data, raw time series data. So both of data formats we deal with. And in case of lag, the lag is there. So thing is that after our Druid, as of now, means what we do is as of now, we have a backup process as well. So this backup process is being used on a day basis. That is part of our ETL. So this is part of our legacy system. And over there, the analyst people, they actually compare that, okay, these, if these are the numbers of users that has been marked by the Druid system. These are the number of system users that are marked for our backup pipeline-based system. So if that number does not match, they raise it to us, and then we do some analysis, and then it is a manual-based process. But yes, that sometimes it happens that lag is there.
Okay, I think what I understand is you're talking about a Lambda kind of architecture, right? Where you have some result from the pipeline as well as some from the real time.
Yes, but this is not at the very same time as I'm saying, because the real-time system is being done. The marking of the user is being done by an application itself, that is tool engine, and the other system that I'm talking about via ETL, via our Spark jobs and all. So this is being done by human who compares this application report and this manual report, and then finds if any anomalies is there, then he will raise a concern. So this is this is how this is handled.
Okay.
And if the lag is something, if just to add, if the lag is something at Kafka ends only, because the RESTful engine and the Druid are reading from the same Kafka. If the data, for some reason, data has not reached this enrichment layer itself, then there is no concern, right? Because once the data is in enrichment Kafka, then only these two systems will get triggered.
Right.
Okay. Any more questions? Okay, great. So this was me, Kundan. You can have any discussions if you feel on. This is my email ID. Thank you for the session.